Welcome everyone to our newest version here of Lunch with Larry. We're going to have a discussion today. We're going to jump right into it with Ryan Miller, our guest, to talk about how we're going to progress. So as we have talked about in the past, our E-BOM, M-BOM, the engineering BOM, progression to the manufacturer BOM. So we talked about design transfer here last week. This week, what we want to do is start to say, we're going to take this design, we're going to put it on the production floor, and we're going to want to understand the line layout and all the simulation activities around manufacturing simulation or plant simulation. And so what we're going to do today is we're going to have this discussion specifically around that tool. I'm going to go ahead and transfer this over to Ryan. Ryan, what you could do maybe is start with a brief overview of our social distancing example and maybe what we're trying to accomplish in the context of this simulation activity. So maybe we just jump right in.
Absolutely, I think that's a great idea. All right, so can you see my screen there, Larry?
Can, dive in.
Excellent, thank you. All right, so what I've found in my 17 years of experience in the manufacturing space is that plant simulation is really positioned to give you the ability to make educated business decisions. And what I mean is, for example, with the social distancing coming up as a hot topic in business, we need to be able to make educated decisions on how we manage our factories and our folks in the factory. And what plant simulation can do is really give you the tools to model those, your workers, your resources, your line, and really put in a good simulation and make good, educated, provable decisions with statistics for your business. As we all know, everybody wants to make educated business decisions, and this is definitely going to be an excellent tool to make those decisions.
Sure. So I'm going to go ahead and just talk about our series here. We have a little bit about me. This is just a slide so that you can show your this series to employees or colleagues. If you want to join us in the last session here next week, which is going to be around manufacturing execution, how do we push this down into execution? All my contact information, if you're interested in any of that, be happy to help you along if that's necessary. And hopefully you have my email here, my phone number. Happy to provide you with any information or progression that I can help you with. The second thing is really Ryan Miller is our guest. Thank you, Ryan, for being here today. Ryan's a product architect here at Siemens, and his role is really specific to our Technomatics product line and plant simulation. So Ryan, maybe you can give us a little background about yourself and let us know what your background is.
Absolutely. So like I mentioned, I'm going on 17 years of experience in the manufacturing space. I've done everything from starting out as a lowly tool and fixture designer with a Fortune 50 heavy equipment manufacturer, all the way up through to planning production areas using the Siemens Teamcenter software, and also planning the production order and sales order scheduling at that same factory. So I've done everything from tool design all the way up through to scheduling a production line.
All right, fantastic. So thanks for the introduction. So let's get into a little more detail with a discussion about how to create a line, populate the model with the base content you needed to do the simulation. So maybe you can just show us how, machines, conveyors, people on the line, all that is created and constructed so that they can get a sense of how this is, how the tool is used.
You bet. Okay. All right, so what I'm going to do here in plant simulation is I'm just going to start with a basic model. Plant Sim gives you the ability to create a model frame that is just basically a clean slate you can start with. However, Plant Sim does have a ton of out-of-the-box elements. We call them objects that you can drop into your model and very quickly model your assembly line from nothing, and you can start getting data very quickly. with maybe just a half an hour for a very simple line, or maybe up to a few hours as you start to add complexity to your line, depending on what granularity level you need to get out of your model. So we'll just start at the beginning here, and I'll just model a very simple line. So the first thing I'm going to do is add a source for our parts. Think of this as your material parts delivery, or it could be a warehouse, it could be anything, it could be a supplier or a paint line or anything like that that's supplying parts to your manufacturing process. When I add this source, it already has defined inside of it that it's going to be delivering parts to the line. This, of course, can be updated, and multiple sources can be added for multiple parts depending on what you need to process. Then I'm just going to add a few stations into my line. And then I'm going to add a few downstream stations straight from my toolbar, drag and drop right into my model space. I can go into these stations and I can set up their processing times using a number of different distributions, whatever makes sense to your business, as makes sense and as you're used to for your business. Once I have the number of stations in my model that I want, I'm also going to add a drain. Think of this as the exit for your process, parts shipped, for example. Okay, and that drain will give you the statistics that you need to track your throughput and various other KPIs that you're looking to keep track of throughout your line. So then, once I have my stations and my model elements that I want, I'm going to use the connector to connect these elements in the process flow that I want to execute. So I'm going to start at my source and connect to my first station. And as I zoom in, you can see that the connector is directional. So the software knows that the material will flow in that direction, very much like a Visio diagram. Again, I'll connect my beginning station to my output stations, and then my output stations to my drain, or to my shipping point, as it were. Okay, now, if I run my simulation, and you'll notice I have a slider bar here, so I can run my simulation at a very slow speed, or I can run it very fast if I want to, and run it for multiple days or even years at a time if I want to get a lot of data. So I'll just run my simulation here. Oh, I need to add a broker. One moment. So I'll add my broker. Set up importer. Sorry about that. It is asking for a broker that I normally wouldn't use here. Sorry about that. I'm not sure why it's actually asking for a broker. Okay. Yep. Okay, so what I'll do here is I'll go ahead and add my workers in here. So what I can do is I can also add my workers in here and show that my workers are coming to my stations and doing work. And what I do is I add workplaces so that my workers know where to go in the model, okay? And then I need to add a worker pool. So think of the worker pool as very similar to your source for your workers, say a break room or something like that where the workers originate. Then I need to tell my stations that I have workers that are going to do this work. So I'm going to come to my stations and turn on the processing using the broker.
So I guess the broker is a negotiation between throughput of the stations. Is that basically what a broker is?
Right. So the broker is like you said, it's a negotiator. It keeps track and it assigns the work to the workers so that the workers know where to go throughout the process. Okay, so now we can show we have a worker moving about through our process. As it's set up here, the worker jumps from one place to the next, but I can change the setup of my workers so that they walk freely within the area or so that they follow a path throughout our process. In this case, the workers are programmed to move freely. Oh, I need to put it in real time. That's what the difference is. So now once I have it in real time, then we'll show the worker moving around from point to point and doing the work as the parts flow through the process. We can change our number of workers in our creation table here. So if we know we have 4 stations, we can input 4 workers here and optimize our line. Again, modeling the line exactly to how our process would normally follow in our factory so that we can get good statistics out on the reporting side. Let's see, another element we can add here, we can add footpaths and we can tell our workers to follow the footpath. So we can tell the simulation that our footpaths are a certain length. We can model those exactly how we need to, and then we can tell the workers to follow that footpath by very quickly modeling that and telling the workers where to go. Then if we want the workers to follow that path, we can tell them only to walk along the footpaths. And those workers will, of course, walk along the footpaths. If there's not a footpath going to their station, of course, they won't be able to follow that footpath and be able to get to their work. So we'll just change that back quickly so that they can actually get to their work. Okay.
So we'll probably talk about this later a little bit about the cost of the line, but I imagine that these trade-offs between workers and how many stations you have and the cost of each is a big part of what we're trying to accomplish here, is to understand what the cost of the line is.
Absolutely, PlantSim definitely has the ability to do cost analysis. We can do it on a station level. We can cost based on the number of workers and their effectiveness. We can turn on energy statistics. I don't want to dive too deep into the KPIs right here at the moment, but we can track the energy usage by station. We can tell it, you know, if you know that this machine is a certain type of machine, we can input those power consumptions into that station and treat it just like that machine. And then as the simulation runs, it'll go through and it'll calculate what the energy usage is, and it'll give us statistics and cost information for those stations.
So can we add in robots, or what other kind of artifacts can we add into the line? Give me a sense of the breadth of it.
Absolutely, we can definitely add in robots. So we have a number of different out-of-the-box setups for robots. The fastest is the pick-and-place robot. It requires just a little more setup than the stations. So we've got a generic, 6-axis pick and place robot here that we can drop into our model, and we can connect that up and show the material flowing between there. And we can have that robot do work for us in our model. There's a number of different advanced ways to set those up to be like a 7-axis robot on a slide. We can program it to traverse between stations. That is more of an advanced topic that we would want to work with a customer on setting those up. But the basics 6-axis pick and place robot is very easy to set up. We can program it to use angles. We can set the times between the different pick and place points. Again, it has all of the energy tracking capabilities. We can also go through any and all of our stations and set up failure modes. So mean time to recovery, mean time between failure. We can go through here and set those up so that we can see, so that we can input our known outage times or delay times on our manufacturing equipment. And then we can really build that into the simulation and see what the impact of those failures would be on our manufacturing process.
So if you have a specific robot type that you're accustomed to using, do those come with, is that part of the library, or would you take that data and input it here just as a known, so you'd have a standard robot that you typically use in this line? I mean, how would you customize it?
So Plant Sim really excels in the bottleneck analysis. We can definitely go through and replace the visual and the graphics for a station. So it is, or for a robot, or for any of our elements, the parts or the conveyors, whatever you'd like to see, that can definitely be done. It all depends on how pretty and how fancy you want to see your model.
Sure.
Is definitely there's definitely a lot of value there, especially when communicating with your internal business partners. You can make the line look exactly like what your shop looks, and more quickly and more readily communicate with your business partners about the subject matter. Definitely.
Sure.
We offer a library of internal, of out of the box models. It's typically best if you have specific models, like say robots from Fanuc or from KUKA or somebody like that, or SMT machines or curing ovens or something like that. If you're in the electronics manufacturing space, it's best to get those models from the manufacturer. They'll carry the space claim and they'll do those things, but it's very easy to bring those into Plant Sim and make them have the space claim that they have. So that in reality.
All right. Well, maybe now that we have sort of a sense of how to build the baseline of the data, we could jump over into our specific KPI in this social distancing model. Would that be all right?
Absolutely. I think that's great. Okay. So I'll jump over to our, I'm actually going to go to my baseline model here of our social distancing model here. And I'll just do a quick reset, and you see how fast the software does a quick reset on our software and wipes out the data in the model. Okay. And what I'm going to do here is I'm just going to run this simulation. So this simulation is set up to have 6 workers that work at 10 process stations. This is our NanoBox plant simulation model. And what it's been designed to do, it's been designed to track the points where the workers interact, where they come closer than 1.5 meters to each other. Okay, so what might happen for business managers, especially with the return to work after social distancing, is that they might simply say, we'll just reduce our workforce by half and therefore reduce our distance violations by half. But that's not necessarily the case. And what this simulation will show is that actually reducing the number of workers may actually increase the number of interactions that your workers have. Okay, so if I accelerate our process here, we can see our distance violations is actually a pretty good number as far as our model goes. Okay, and that's because we have 6 workers running 10 stations. Those workers have to move around and come pretty close to each other. Plant simulation calculates the minimum path for a worker, either along a walking path or in an open space, as you can see. And the workers will the model, I should say rather, will track as those workers interfere with each other, or as they come closer to each other than what we would like in our new environment, right? So what we can do here is we can do, so now that we have our line modeled and we have our software working so that we can actually keep track of these interactions, we can actually start doing what if scenarios. What if we increase the number of workers, or what if we take some actions um, to limit the interactions of our workers? It may not always be, we as businesses may not just want to flush the line with workers and thereby reduce the number of interactions. It may not always be possible. Maybe 6 is the ideal number of workers for your assembly line. So what we can do, and one of the things that plant simulation does out of the box, is it keeps track of the obstacles in the model, and the workers will avoid those obstacles. So I've turned on here the red highlighting, and what that's showing is that all of these elements are obstacles for the workers, and the workers will move past those obstacles. They will not walk through them, okay? So I'm going to switch over to my standard model here, and what we've done is we've added obstacles for our workers. So same number of workers, same exact assembly line, same shift period, but the workers now interact much less. We've made it so that their walking path directs them around each other. Instead of walking nearby each other, now they have to walk around each other, and they're forced to stay away from each other more often, okay? And we can see that our number of distance violations is greatly reduced. If I run this for a full hour, so I can accelerate it and run this for a full hour, we can see that our distance violations are greatly reduced over the same period of time. They do still interact, that's unavoidable, it is an open space, but we've actually done a what if simulation here, and we've actually gotten some value and and given ourselves some knowledge here, some statistics, some elements that we can actually say, okay, these are the right business decisions to make to add these partitions to our line, instead of making sort of seat of the pants reactionary business decisions without any kind of proof that it's going to have the effect that we intend.
Sure. I would think too that when you're in a model like this and you're starting to make changes, you know, for example, your example of let's pull 2 workers out of the line, what you might get is a reduction in the number of interactions, but it might also greatly affect either throughput or maybe your product bottlenecks and really mess your lineup. So maybe you could talk a little bit about other KPIs like this first one about about bottlenecks in the line and the effect of bottlenecks. Maybe that would be.
Absolutely. So we've got a number of different elements that let us, that give us, not just let us, but help us to analyze those bottlenecks and to look at those KPIs, as you mentioned, that we want to see. So we have, first off, we have a Sankey diagram that shows us the tracking of whatever movable unit we call the workers, we call the parts MUs, or movable units. And what it does is it lets us track those in a weighted format. Okay, so if I turn on my Sankey diagram here, I can see the worker movement throughout my line. So instead of just having the distance violations popped up, I can actually see the worker paths now overlaid on the line. The thicker lines mean that the workers travel those paths more often. The thinner lines mean less often, of course. And I can do the same thing. If I take my material flow object and put my part in there, that is a PB60. So if I go to user object and put my PB60 on my Sankey diagram, I can now track my number of parts through the line. I think I have to change it in a little different way here. And, oh, I have to actually run the model. That's one object we have to actually run the model before it will actually track that element through the line. So now we can see our material flowing through the line. Okay, so as far as the KPI goes, we can take a look at, so that gives us one visual way of seeing the part, the material flowing through the line. Obviously, this is an overly simplified line that there's no branching and returning. But with a reality, with a real line, you would see all of those parts flowing through, and it may give insights into bottlenecks or into areas where the material flow could be simplified, or it may give just simply education on interactions that you didn't realize were even happening. So
Or
one of the
even
things,
if you had a sink, you could maybe discuss how an AGV would be used in the context of both, right? So maybe,
absolutely, yep.
Yeah, sure.
Yep. So AGVs are an advanced topic. It takes a little more setup than what we have time for here today. I don't want to go over an hour just to set those up. That is definitely something, if our customer is interested in modeling AGVs, we would definitely spend time to show them what PlantSim can do for them on that. Definitely. One thing I did want to show here real quick in the drain is all of our stations have a lot of different statistics. We can show the throughput per hour, throughput per day. There's a couple of hundred different statistics that this is tracking. And all of these can be brought out into HTML reports in a lot of different places and made useful so that you don't have to export the data and crunch it in Excel or something like that. It's all right here within PlantSim.
Sure. I got a question from the audience. They're asking how detailed we can get in the context of the station. So, for example, can you view a blank going into the machine and possibly coming out of a finished conveyor or something? So they're really asking, how detailed can you get in these in the stations themselves? Can we drive it down to a specific design level even?
Yeah, absolutely. You can have the station replace the graphic for the model so that it looks like a blank going in one side and a finished part coming out the other. Like I said, PlantSim is really more about the time and throughput modeling. It's not necessarily like a CAD software, like say NXCAM or something like that, right? Where you're really getting really deep into the process. Think of this as macro level versus micro level of something like NXCAM or Process Simulate, where you're really going to go in and touch the points and the angles and really get deep into an individual station's processing. But definitely nice to haves like that are definitely possible, certainly.
Yeah, you bet. So just the last question, I don't know if you have any other thoughts on other KPIs that we might be tracking. I think you talked a little bit about material flow, but and energy analysis, cost analysis, anything else that you can provide us, or we pretty much,
absolutely. One more that I'd like to show here, we have something called a bottleneck analyzer. We can just simply drag and drop it into our model here. And I'm going to hide my Sankey just to simplify the display here, but the bottleneck analyzer can be shown, and it will show the station statistics in a chart mode. Okay, so like the green, for example, is good working time. Orange would be block time, and gray is waiting time, for example. So just a really good one that makes it visual for you to be able to very quickly do analysis on your model and see information about your assembly line.
Yeah, really nice to get these statistics before you go and change everything on the line and find out it's messed up, right?
Absolutely, yeah. It lets you make informed business decisions before buying a $500,000 machine that you maybe don't need. So, yeah, absolutely.
All right. Well, I really appreciate the show through the tool. That's it for today. You have operational excellence. Next week, we're going to talk about the next series. We're going to do design excellence again. We're going to step back into the design world, talk about mechanical design, some product performance simulation, so simulation on the product itself, And also, we're going to have some discussion about electrical simulation. So that's the next series coming up. We'll have a registration for that next time. But thanks for coming to lunch with Larry today, and I appreciate all your time and consideration. So look forward to talking to you next time.